Hi guys, welcome back. In this video, I'm going to discuss about our next module, which is the module 5 of our ITN, Introduction to Networks course. In this module, we are going to talk about the most core concepts, something called the number systems. So let's get started. So what is a number system? A number system is a system of writing to express numbers. So it is basically how do you represent numbers? We use it every day in our life. Most notable the number systems that we use every day are the decimal digits, which you use 0 to 9, the binary number system, the octal number system, and the hexadecimal number system. So let's see, the reason behind why we are studying these number systems as part of CCNA course is pretty simple. Because in our networks, we use IPv4 and IPv6 addressing. In order to study these addresses, in order to understand these addresses, you must have a very good knowledge about the decimal number system, the binary number system, and hexadecimal number system. So in this particular module, we are going to cover both the number systems and how to convert from one to another, and how do you read the IP addresses. This is like a support module, which you might not get many questions, or you might not get questions at all in your exam. But if you read this, you will get a better understanding about these number systems and how do you represent these IPv4 and specifically IPv6 addresses. So these are these are the module objectives. If you see, we are going to study about the two number systems, which is the binary and the hexadecimal number system. We are going to calculate how to convert between these two things, and more specifically, most importantly, how do you read IPv4 and IPv6 addresses? Okay, so let's start with the first and the basic one, binary number system. Now, in binary number system, the name itself gives you, it's a giveaway. There are only two things in binary. It's 1 and 0. We usually call them bits. In a decimal number system, we usually have digits which are 0 to 9. So 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So these are digits, and we use them in decimal number system. So it is most commonly found in each and everything you use, in your PIN numbers, in your phone numbers, everything. So in communications, or for specifically for computer usage, we prefer binary. Binary, as I said, it's only zeros and ones, and we use bits. As I told you, the hosts, servers, and all the network equipment use binary addressing to identify themselves on the network. Each address, which is nothing but your IP address, it is made up of a string of 32 bits, which is divided into 4 sections. These 4 sections are called as octets. I will show you some examples. So each octet contains 8 bits or 1 byte separated by a dot. So usually when people try to remember the IP addresses, it becomes very difficult for a human being to remember 32 ones and zeros, or a string of 32 ones and zeros. So for ease of usage and writing or even remembering the IP addresses, we generally convert them into decimals and remember them as decimals. Now in this example which is shown here, if you see, usually these addresses are shown as 111010001.100. All these things are written down here. Now for me to go and for me to remember all these addresses which are in binary format, it becomes pretty much difficult. So for that reason, simply for ease of usage, what we usually do is this binary address is actually converted into decimal form. If you see here, this binary address equates to decimal form, and we usually remember this as the IP address of that particular host, whether it might be a server, it might be a router, or it might be any other device on the network. Usually when it is connected to the network, it will have an IP address attached to it. So for me to identify those particular components, or to identify the particular devices on the network, I generally have the IP address attached to it. So this is how, or this is why we usually take the IP address in the decimal notation. Though in internally for the computer usage, it's always in binary. It's always ones and zeros. Now this is the positional notation. It is very much known to most of you. The thing here is positional notation gives, or it means that a digit represents different values depending on the position the digit occupies in the sequence of numbers. Specifically, if I just straight away, let me take you to this particular example, which is 1234. The positions are nothing but powers of 0, powers of 10. So 10 power 0 is the last position, 10 power 1, 10 square, 10 cube. That means it is 1's position, 10's positions, 100 position, and 1000 position. Now for 1234, what we usually do is the 1 is placed in the thousands position. So 1 into 1000 gives me 1000. 2 in the 100th position, 2 into 100 gives me 200. 3 in the 10th position, which is 1, 2, 3, 30. And finally, the 4 is in the ones position. So if you multiply all of them together, 1000 plus 200 plus 30 plus 4 gives me 1234. This we have studied long ago, and most of you must have known this. So let me just skip that part. Let's come to the binary part. The binary also works in the same notation as your decimal. Here also the positions are important, but rather than having powers of 10, here we usually calculate using powers of 2. So the leftmost or the rightmost position we start from is 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5, 2 power 6, and 2 power 7. So 2 power 0 is 1, 2 power 1 is 2, 2 power 2 square is 4, 2 cube is 8, 2 power 4 is 16, 2 power 5 is 32. So what does this mean? So if I give you a binary number, so let us take as an example here, I'm taking the binary number as 11, 000, I have given you this binary number. Usually when I say about binary numbers, we talk in 8 bits or 1 byte. So 1 byte is equal to 8 bits. So we usually talk them in bytes because it makes it much more easier for you when you're studying IPv4 addresses. A byte is 8 bits, and usually an IPv4 address is 32 bits in length. These 32 bits are actually divided into 4 parts, and each part is called as an octet. So 4 8s, 32 bits. Okay. Now, that is the reason I have taken the binary numbers as 8 bits. Now, for me to find out what these 8 bits are, or what is the decimal equivalent of these 8 bits, I simply write them down here like this in this table and write the positional reference of powers of 2. So 2 power 0, 2 power 2 square, 2 square, 2 cube, 2 power 4, 2 power 5, 2 power 6, 2 power 7. So the highest value given is 128. So 128, there is a 1 position here. So 128 into 1, there is a 1 placed in the 64 position. So 64 into 1, 128 plus 64. And the rest of all are zeros. So 128 plus 64 plus all zeros gives me 192. The decimal equivalent of this binary byte or this byte or these 8 binary bits 11000000 is 192. In this way, we usually calculate decimal from binary, and it's vice versa thing from decimal to binary and binary to decimal. Now let me show you. This is how. I have given you a 32 bits. As I told you, IPv4 consists of 32 bits, and these 32 bits, if you see here, these 32 bits are actually divided into 4 parts. So all of these are 8 bits. So all of these are 8 bits, and it's divided into 4 parts. Each part is called as an octet. So this is an octet, this is one octet, this is one octet, this is another octet. We have 4 octets here, and 4 8s are 32 bits. Now for me to calculate an IPv4 address or the decimal equivalent of an IPv4 address which is given in binary, you follow the same steps that we just discussed. So write them down, write it as a part of a table, write the powers of 2 on top, and then calculate it. So we just did this. So we did the 11100000 part. We got 192. Let's take the second octet, 10101000. I have written them down here, and let me just do the same calculation once again because it's powers of 2. I have 1 here, so we have 128 here. So 128. I have a 0 in 64, so I just put a 0 here. I have 1 in 32, so I put a 32 there, and there is a 0 here. I put a 0 here. There is a 1 in 8th position, so I put 8 here plus 8, and the remaining are all zeros. So when I calculate, it gives me 128 plus 32, which is equal to 160, and plus 8, which gives me 168. So in this way, if I keep calculating the decimal equivalents for all these 4 octets, I usually get my IPv4 address, which is 192.168.11.10. That is my IPv4 address for this binary equivalent. Okay. So in this way, we usually calculate. But believe me, once we go deep into the CCNA course, you have to have a very good idea, and you have to be very fast to convert such things, because we come across subnetting, and you need to have an idea how to convert fast into decimal and binary with these binary representations of IPv4 address for you to get a good grasp about subnetting concepts. Now let me go further. This is what, how do you convert a decimal into binary conversion? It's given as a series of steps. So let me just tell you how it is done. As I told you, usually each and every octet, that means 8 bits, the highest position in this value is 128. So if whatever decimal digit is given to you, you have to go through these 4 steps and then find out what is the binary equivalent for the given decimal value. Let me put it in simpler terms. As I told you, they have written down these values here. These are your powers of 2 till 2 power 7, 2 power 0, 2 power 1, 2 square, 2 cube, 2 power 4, 2 power 5, 2 power 6, and 2 power 7. Now let me take, now he says, he's asking the first step you have to do is whatever value is given to you, first check whether it is greater than 128 or not. If it is not greater than 128, simply put a 0 here. If it is greater than 128, you put a 1 in 128 position and minus that particular value from 128. So whatever is left remaining, you keep on continuing this process. I'll take a simpler example for you to understand how do you get the binary from the decimal digits. Now let me show you. As an example, I have taken 168. Now I got the value as 168. Now how do I get the binary equivalent from this particular 168? To start, as I said, the very first step that we usually do here is whether the given decimal value is greater than 128 or not. It is. So I placed a 1 in the 128 position. If you see here, I placed a 1 here. Now, once I place a 1, I have to subtract 128 from 168. I got a remainder of 40. Okay. Now let me compare. What is the next one after 128? The position is 64. Is 40 greater than 64? No. So I put a 0 there because 40 is not greater than 64. I move on. The next position is 32. So when I have 32, once again I compare. Is 40 greater than 32? Yes. Now I put a 1 in the 32 position. Okay. Now once I put a 1 here, I have to subtract 32 from 40. I get a remainder of 8. Now let me move to the next position. It is 16. Is 8 greater than 16? No. So I place a 0 here. Move on. Now is 8 greater than 8? It is equal. When it is equal, I place a 1 there and I move on. When I subtract, I get a 0. Because I got the remainder as 0, I put zeros in all the remaining binary positions. Simpler terms, just make a table here because you know that there are 8 bits in any octet of an IPv4 address. Simply write them down 1, 2, 4, 8, 16, 32, 64, 128, and whatever value is given to you, just do this simple calculation and you can get the binary equivalent of any particular address. So there are many examples that you can do on your own. I suggest everybody to take 1 or 2 simpler things like you can take 198, you can take 225 because the highest value is 255. You can take up to 255. So you take those 1 or 2 values and try to do it on your own so that you will get a good understanding of how can you get the binary equivalents. There are many things written down here. I have given these things. Once again, I want you to, I just want to remind that each and everyone that you are studying these things because you need to have a good understanding of how do you convert decimal to binary and binary to decimal when you are working with IPv4 addresses. Because we will be studying subnetting and in the future about routing, and we will be working both on IPv4 addresses and IPv6 addresses. This particular knowledge will help you to understand the things much more faster and also to solve the subnetting problems in an efficient manner. Okay, so this is regarding your IPv4 addresses. And let me take you to the hexadecimal number system. In the hexadecimal number system, the reason why we study hexadecimal number system is simple, because IPv6 is written in hexadecimal. So to understand IPv6 addresses, as I told you, you should be able to convert hexadecimal to decimal and vice versa. What is hexadecimal? As I told you, decimal means you have 0 to 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 digits. Binary means bits, only 0 and 1. Whereas in hexadecimal, you use a combination. You use digits from 0 to 9 and letters from A to F. Hexadecimal is also called as a base 16 numbering system. So you use the digits from 0 to 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we proceed on to A, B, C, D, E, and F. All IPv6 addresses and each and every MAC address, medium access control, MAC address are actually written in hexadecimal only. So, because, sir, you can ask me, I mean, or you might have got a doubt. So why do you bother about hexadecimal? Why can't we simply write it in decimal or binary? Because your IPv6 address is 128 bits in length. It's not 32. It's 128 bits in length. It is 4 times larger. Okay, so in order for you to remember all those things, it becomes a very, very big headache, even in decimal also. So to make it much more easier for us to remember or to write it down or to represent them, we tend to go for your hexadecimal representation. Even the MAC address is 48 bits in length. So for me to represent 48 bits, it is much more easier if I use the hexadecimal notation. Okay, so if you see here, the IPv6 addresses are 128 bits in length, and here each 4 bits is represented by a single hexadecimal digit. That means it makes the IPv6 addresses a total of 32 hexadecimal values. Earlier, I told you in IPv4 addresses, the entire address is divided into 4 parts, and each part is called as an octet. So 4 octets, 4 8s, 32 bits. Here, in the same manner, your IPv6, which is 128 bits in length, I write them into 8 parts. If you check it out, 1, 2, 3, 4, 5, 6, 7, and 8. I have 8 parts. Here, each part is called as a hextet, H-E-X-T-E-T, hextet. So 8 or each hextet means 16 binary digits. One hextet is equal to 16 binary digits, and I have a total of 8 hextets. That means 8 16s, which is equal to 128 bits. So this is how we represent, and I have brought in you a small example to get a feel about how IPv6 addresses are written down. So this is a IPv6 address. Here, each one of these values actually represent 4 bits. Here F is 4 bits, D is 4 bits, E is 4 bits, C is 4 bits. So this part consists of 16 bits, and it is called as a hextet. And we have such 1, 2, 3, 4, 5, 6, 7, and 8. So 8 hextets in total. You will get the 128 bits length of your IPv6 address. Please remember this, IPv6 is 128 bits in length, because it solves each and every problem or most of the problems that your IPv4 has regarding the address domains. Okay, we will discuss it in our further chapters. Okay, now if you check it out, the hexadecimal, or how do you convert the decimal to hexadecimal conversions? It is also pretty much straightforward. The thing here is, first you need to, in order to convert a decimal number to hexadecimal, what you need to do is you need to convert the decimal number to 8-bit binary strings. You cut it out into 8-bit binary strings, divide the binary strings into group of 4, because it's starting from the rightmost position, and then convert each of these 4 binary bits into their equivalent hexadecimal digit. Let me take an example, it becomes much more clearer. So let us take this again, 168, which you have been using from the start of this module. Let me take 168. The binary equivalent of 168 is 10101000. As I told you, this is an 8-bit binary. You have to divide this into groups of 4. So I have 2 groups here. So 1010 and 1000. The equivalent of 1010 is 10. 10 is actually written in hexadecimal as A. 1000 is nothing but its decimal equivalent is 8. So 168 is actually written as A8 in hexadecimal. Once again, I'll repeat the steps. You take the number, you convert it into binary, and divide the binary 8 bits into groups of 4. That means you have 4 bits, and each of these 4 bits, whatever its equivalent in hexadecimal, just write it down there. That's all. This is how you actually convert a decimal number into hexadecimal. But what about the reverse one? What about converting a hexadecimal into decimal? This is how you do it. I have something called as a D2. So I need the decimal equivalent of E2, D2. So D2 in 4-bit binary is 1101, and 2 is written as 0010. Combine them together, 1101, 0010, and then you apply the same thing that we just discussed in the start of the module. Write powers of 2 on top. Then you will get the 210. This decimal equivalent is given as 210. Okay, so D2 is written as 210 in decimal. So I'll just repeat this. So you have been given a hexadecimal number here, and for this hexadecimal number, what you have to do is you have to break it up into its binary, and in this binary, what you have to do is you have to see, this is 1 4 bits and this is 1 4 bits. D is written as 1101, 2 is written as 0010, and you combine them together to form your 8-bit grouping, and then apply just powers of 2. So 1 2 4 8 16 the same manner. Okay, 16 32 64 128. So 128 plus 64 gives me 192. 192 plus 16 gives me 208. 208 plus 2 gives me 210. So this is how you get the decimal equivalent of your hexadecimal. It is very simple. As I said, this is a very small module, which is just a support module, which will help you to understand about binary to decimal conversions, decimal to binary conversions, and hexadecimal to binary and to decimal conversions. And so the primary objective is for you to understand how to study IPv4 and IPv6 addresses and how do you represent these addresses. That's all. So let me just summarize these things for you. As I told you, binary is a base 2 numbering system that consists of the numbers 0 and 1, which are called as bits. Decimal is a base 10 numbering system, which will consist of digits 0 to 9. And most of the networking equipment or hosts or even routers and everything has an IP address attached to which is written in binary. And hexadecimal is a base 16 numbering system, which consists of numbers 0 to 9 and letters A to F. And hexadecimal is used to represent IPv6 addresses and MAC addresses. And also, most importantly, IPv6 addresses are 128 bits long, and each one of these 4 bits is represented by a hexadecimal bit for a total of 32 hexadecimal digits. To convert hexadecimal to decimal, you first convert it to binary and then convert the binary to decimal. In the reverse process, you have to convert decimal to hexadecimal. First, you convert the decimal to binary and then binary to hexadecimal. Hope this is helpful for you. And so in the next module, we will be covering about the data link layer. So thank you very much.